Assalamu alaikum dear students. This is lecture number 7 of chapter number 11, triangles, quadrilaterals and polygons. So we start this lecture with the polygons. Polygon is any closed figure that has sides. So these are the examples of polygons. Like triangle, you can see that this figure has 3 sides and it is a closed figure. Similarly, quadrilateral has 4 sides, 5-sided polygon, then 6-sided, then 7-sided, 8-sided, 9-sided and 10-sided polygons. All of these figures are polygons because they have sides, and because each of these figure has sides and it is closed. It is a closed figure. So it's a triangle, quadrilateral, and 4-sided polygon, and 5-sided polygon is known as pentagon. Whereas 6-sided is known as hexagon. Seven-sided heptagon and 8-sided octagon. Then 10-sided decagon. So we have studied about some different types of polygons. Next thing is the sum of their interior angles of an n-sided polygon. Interior angles means the angle inside of this polygon. Like in this polygon we have 3 angles, 1, 2 and 3. These are the interior angles of polygon. Similarly in quadrilateral, 1, 2, 3 and 4. In pentagon we have 5 angles. Hexagon, 6 angles. Obviously 7 angles will be in heptagon, 8 will be in octagon, and finally 10 angles will be in decagon. So for any polygon, the sum of its interior angles will be equal to n minus 2. N is actually the number of sides of this polygon, n minus 2 multiplied by 180 degree. So we apply this formula in the questions of exercise 11C. Exercise 11C, question number 1. Find the sum of the interior angles of each of the following polygons. Equal to n minus 2 into 180 degrees. So here n is 12, so it means n minus 2 will be 12 minus 2 into 180 degree. 12 minus 2 gives you 10, so 10 multiplied by 180 degree. So the sum of the 12-sided polygons, the sum of the interior angles of 12-sided polygons will be 1800. 10 into 180 is 1800 degree. Okay, question number 2. Find the value of the unknown in each of the following figures. So if you see, all of the figures have interior angles given. So we will use the sum of interior angles of polygon formula to calculate to find the unknown value. I am doing part C first. In part C you can see that interior angles are 101, 2C, 38, 152 and C. So writing the formula first, sum of interior angles of polygon will be equal to n minus 2 into 180 degree. So at left hand side we will add all of these angles. The first angle is C plus 101 plus 2C plus 38 plus 152. So this is actually the sum of the 6 1 2 3 4 5 sided polygon. So it means the value n will be 5. So I'm writing here n minus 2 means 5 minus 2, because this polygon has 5 sides. Multiply 180. Okay, simplifying it, C plus 2C 3C, and 101 plus 38 is 139. 139 plus 152 will be 291. Equal to 5 minus 2 3 multiplied by 180. So 3C equal to 3 into 180 is 540, and this 291 gives becomes negative there, minus 291. So 3C equal to 540 minus 291 will be equal to 249. So C will be equal to 249 over 3. So finally we get C equal to 83. Similarly, in part D, the sum of interior angles of polygons is equal to n minus 2 into 180 degrees. Okay, adding all of these angles, the first one is 4D, then 108, then 4D again, plus 4D, plus 5D, plus 102, and this will be equal to n minus 2. N is 1 2 3 4 5 6, so it is actually 6-sided polygon. So 6 minus 2 into 180. So 4D plus 4D, 8D, 8D plus 4D, 12D, 12D plus 5D, 17D. 17D plus 108 plus 102. So it will be 210 equal to 6 minus 2 is 4, and 4 multiplied by 180 gives you 720. So 7D equal to 720 minus 210. Or D will be equal to 720 minus 210 is 510. So D will be equal to 510 divided by 17. So in the end we get D equals 30 degree. So this is the final answer of part D. Okay, next question, question number 3. Find the sum of interior angles of a regular hexagon. Regular hexagon is actually a polygon that has equal sides. It means its each interior angle, or all the interior angles are equal for a regular polygon only. So part A, and it's first. Sum of hexagon means 6-sided. So I'm writing the formula first. Sum of interior angles polygon will be equal to n minus 2 into 180 degree. And as it is a regular polygon, it means all the angles are equal. So there are 6 angles. So if I suppose each angle is x, then their sum will be x plus x plus x plus x plus x equal to 6-sided means 6 minus 2 into 180. So it will become 6x. So if you look at this, 6x is actually the product of a number of sides with each interior angle, which is x. So 6 minus 2 into 180 is 720, or x will be equal to 720. So it is actually a sum. Sum is 720. So you can see that their sum is 720. So part 1 answer is 720, whereas in part 2 we have to find the interior angle. It means we have to find the value of x. So x is equal to 720 over 6, or x is equal to 120. So 120 is actually the each interior angle. Okay, next part B. Find the sum of interior angle of a regular polygon with 18 sides. So very similar question. So I'm doing it directly. Sum of interior angles will be equal to n minus 2 into 180 degree. As we have seen in the previous part that sum of interior angles of a regular polygon is number of sides multiplied by each interior angle. Suppose each interior angle is y, then it will be n multiplied by y. Now inserting the value of n is what? 18 sided. So 18 multiplied by y equal to n minus 2 means 18 minus 2 multiplied by 180. So 18y equal to 18 minus 2 is 16, and 16 multiplied by 180 gives you 2880 degrees. So y will be equal to, so basically this is the sum. So part 1 done here, 2880, and part 2 will be size of each interior angle, which is y. So y is equal to 2880 over 18. So it is 160. So each interior angle is 160 degree. Alright, part 2 also done. So we have solved question number 3. Next question, question number 5. Find the number of sides of a regular polygon if each exterior angle of the polygon is this. So you must remember that sum of exterior angle of any polygon is equal to 360. So I'm writing the formula first. Sum of exterior means the angles outside the polygon of polygon equal to 360. Of any polygon, three-sided, four-sided, five-sided. So it means number of sides do not affect the sum of polygon, sum of exterior angle of the polygon. So I'm doing part C first. Part C, we have exterior angle is given, which is 12. So I'm writing the formula, this one, sum of exterior angle of polygon. As it is a regular polygon, it means each exterior angle will be equal to the next one. So all the exterior angles are equal, so I can write here the sum of exterior angle will be number of sides multiplied by each exterior angle. Suppose each exterior angle is Z, equal to 360 degrees. So number of sides n, as it is, we have to find it. Value of Z is 12. Each exterior angle is 12 and equal to 360. So number of sides will be equal to 360 divided by 12. So n will be equal to 30. So number of sides of this polygon is 30. So if we say these polygons, the exterior angles will be drawing the angles with blue color. Suppose this is the line, and this angle is the first exterior angle, extend this as well, second exterior angle, now this line, and third. So the angles shown with the blue color are exterior angle of this three-sided polygon or triangle, whereas the four-sided exterior angle is first this, then second, then third, and then fourth. So all of these angles are exterior angles. In a regular polygon, the exterior angles are equal, whereas if the polygon is irregular, the angles cannot be equal. All the angles cannot be equal.